Hey guys, welcome to second derivative test. In this lesson we're going to be learning an extension of the concavity and the second derivative lesson. The second derivative test will help us find relative max and relative min much more easier, sometimes, not all the time. So let me go ahead and begin by um, briefly explaining what's going on max and mins. So here I have an exercise that you guys have done already, and here I have concavity. I have a concave down curve here, and then it goes to concave up, concave down, somewhere here it changes to up, and then up forever. Now, since we're talking about max and mins in this video, when x has a maximum, what is the concavity of this maximum here? And if you look at the top right of the screen, you have concave down. What about minimum? You have a concave up. Again, maximum, concave down, minimum, concave up. So that should tell you something. Whenever you have a maximum, your graph has to be a concave down. And whenever you have a minimum, your graph, well, I'm sorry, not has to be, but your graph will be concave down. And a minimum means that you probably have a concave up, and then so on. So let's go ahead and go back to our notes. So that means that concave down, you're more than likely to have a max, which means the second derivative must be negative because it's concave down. Concave up, you're more than likely to have a minimum, and that means the second derivative must be positive because it's concave up. So let's go ahead and complete the second derivative test here. Let f be a function such that the second derivative of f exists, which also means twice differentiable, on an open interval containing c. If f prime of c is equal to 0, what does it mean for a value to be 0 and the derivative? It means you have a critical number here. If f prime of c is equal to 0 and f double prime of c is positive, in other words concave up, we're talking about the same c value. So we're getting the critical number and we're plugging it into the second derivative, and it must mean that that point c has to be a relative min. Relative min because of up here. Now if f prime of c is equal to 0, another critical point, and that same c value gives you a second derivative of negative, then that means that the point c comma f of c is a relative max, which is up here. Last, number 3, if f prime of c is equal to 0 and the second derivative still gives you a 0, then the second derivative test failed and you have to revert back to the first derivative test, which is the whole number line increasing decreasing way of doing this. So like I mentioned before, second derivative test is another test to determine max and mins. Will it always be the shorter way? Probably not, but we're going to see how it works either way on this example. Example number 1. Given f of x, use the second derivative test to find whether f has a local max or min at x equals 3. So they're telling you here that x equals 3 must be a local max or min. So let's go ahead and find our critical number. F prime of x is 2/3. F prime of x, using the power rule, becomes 2x squared plus x minus 15. Setting it equal to 0, you should get a quadratic, and sometimes these quadratics are not so obvious to solve, so I'm going to use the ACB trick. A times C, B. So this is A, this is B, this is C. What is A times C? That's negative 30. My B is a positive 1. That means that my smallest number, my factor, has to be a negative. So let me go ahead and list all the factors of 30. Negative 130, negative 215, negative 310, negative 5, 6. Now which one of these gives me 1 if I add them? Negative 5 and 6 gives me 1. So I have my factors. 2x minus 5, sorry, 2x minus 6. Now you guys are probably thinking, well sir, 2x and 2x does not give me 2x squared. Well, it definitely does, because this is just an equation. I can factor out 2 out of here and here and divide it to both sides, so I get 2x minus 5, x minus 3 is equal to 0. Or you could just separate and solve and you still get the same solutions, which is x is equal to 5 halves and positive 3. Well, I'm sorry, plus. It's supposed to be a plus right here. I'm sorry, plus plus, so negative 3. So I have two critical numbers. Second derivative test says use the critical numbers, plug them into your second derivative, and determine the signs, and that'll give me your max and your min, or in some cases maybe it wouldn't work. So let's find our second derivative. The second derivative is the derivative of the first, so it's going to be 4x plus 1. Now let's go ahead and plug in our critical points. Four times 5 halves plus 1 is surely positive. 4 times negative 3 plus 1, that is definitely negative. So this is a max, I'm sorry, this is a minimum, this is a maximum. Let me go ahead and explain. It can be very overwhelming. I know we're learning things that are new. It says here, if you plug in the critical number into your derivative and your second derivative and you get a positive, you have a minimum. So here's my critical number, it's positive minimum. If you plug in your critical number into your second derivative and it's negative, then you have a max. So notice, here's my critical number, I plugged it in, I got negative, which is the max. So let's go ahead and justify our answers. So at x equals 3, at negative 3, we have a maximum, not a minimum. So let's go ahead and write our answer. At x is equal to negative 3, f is a local relative, same thing, local maximum, because, and you're going to write exactly what it is up here, number 1, because f prime of negative 3 is equal to 0, and f double prime of negative 3 is positive, period, and you're done. That is your solution. You're using calculus to explain your solution. F prime of negative 3, which means a critical number, and f double prime of negative 3, which means concave up. And your AP readers, they know all the rules. They know all the rules. They know all the calculus rules. They're the calculus experts, and they know what you mean by that. And you're done with that example. So I'm going to go ahead and complete the rest of the examples in another video.